All right, let's get going. Good morning. Good morning, ladies and gentlemen. Welcome. Welcome to today's session, and welcome to the second day of MEC. Looks like my voice is probably echoing a bit, is it? Yeah. That might be because of yesterday night. With that being said, hope you guys had a good day yesterday and night. I believe it was a lot of fun at Rainy Street. I was seeing Yammer posts all night long. Is the voice better now? Can you guys hear me okay? Cool. So we have a packed session today. My name is Khushru Irani. I'm a program manager in the transport team. And my team basically is responsible for two things. Number one, we build and develop transport code for Exchange. We also manage and maintain mail flow for Office 365, the service. You know, I must share this story with you, actually. About a year ago is when I joined the transport team. And before then, you know, my perspective of email was very different. I was just a regular user. You know, I used to send mail, receive mail, and pretty much took mail for granted. Has that perspective changed? I still receive and send mail, but I don't take mail for granted anymore. And I say that with the utmost respect, because the power and the responsibility of maintaining, for instance, mail flow for your organization is immense. And I have great appreciation, in fact, for the work that most of you have been doing for many years now, managing and maintaining email flow for your institutions. So that being said, let's get on this journey together and see what transport brings for us in Exchange 2013. So I have a lot of topics to cover. I want to cover all of them. I might not have sufficient time for Q&A. However, there are two unplugged sessions, and I request that you attend. There's one after this one, and there's one next day, tomorrow. So if you have any questions pending, please, we can address those then. But I want to cover all of these things in its entirety today. So let's dive right in and look at first just an overview of what Exchange 2010 and 2013 is. Now, most of you attended the session yesterday, so I won't go through a lot of it. It's just a slide and my perspective of how things have changed for us. If you look at Exchange 2010, you had the three roles, the CAS role, the hub role, and the UM role. And you also had mailbox. Now, each of these roles, if you look at them, they performed a little bit of both aspects. Number one, they both performed, or all three performed authentication, proxying, redirect. They also had business logic, right? And, you know, mail flow came in, went through the hub, and went to the mailbox database. And that's generally how things work. Fast forward to 2013, and there's been role consolidation for sure. So all the three roles that I have there, the CAS, hub, and UM, have all moved over to the mailbox server. Now, the hub role is not really called the hub role anymore on the mailbox server, but this is more for illustration purposes. You had all these three roles move over to the mailbox server, and you had this thin layer on the top, which was the CAS server. And the CAS server still performed the functions that it was performing to some extent before, which was authentication, proxying, redirect. Now, there are a lot of advantages of role consolidation. number one, for instance, the way I look at this is you have fewer roles to deal with for sure, and that means fewer roles to profile. Your hardware, you don't have to build a hardware profile for your hub role or your UM role, and so on. You just have to worry about hardware profiling for your mailbox server and your CAS server. The other thing that role consolidation brings you is, let's take, for example, the hub. The hub is quite processor intensive and memory intensive. The mailbox server, on the other hand, is database disk intensive. When you combine the two, for instance, you achieve, to some extent, economies of scale. You are able to utilize the resources on the box much better than what you were before. So from that perspective, the role consolidation helps. And lastly, you have the CAS server, and you could have an array of CAS servers, and they are providing some level of network isolation between the internet and your backends. So when I look at all of these three pieces together, the consolidation aspect makes a lot of sense. Now, let's focus more on how mail delivery or transport has changed between 2010 and right now. Now, in 2010, you had mail flow used to come into the hub directly via SMTP, and the hub used to make MAPI calls via the store driver into the mailbox server and deposit your mail. The same thing would happen, for instance, if it hit another hub, and mail flow would go from that hub to a hub in the site where the mailbox is, and mail again would be delivered using MAPI to the mailbox. Now, notice I'm going to be stressing more on the protocols that are being used between different servers and less on actual routing, at least in this slide. But there's a reason for that. If you look at 2013, all traffic via SMTP hits your front end. Your front end, actually, maybe before I do that, maybe I take a step back. When you look at the picture on your right-hand side in 2013, you no longer have the hub as we know it, but you have the front end, you have the transport component, and you have the mailbox transport component. So you actually have three components, which it used to be the hub before. So mail comes in, and we'll talk about these in detail later. Mail comes in via SMTP, hits your front-end server. Your front-end server then talks SMTP again with your transport service, which then talks SMTP to your mailbox transport service. And finally, it is only the mailbox transport service that talks MAPI to the store. So right here, you have MAPI only on the local box between mailbox transport and the store. Same thing happens when another CAS server were hit. So if you hit another CAS server with SMTP, that hits transport again in the same site here. And now you have a call made by that transport service to mailbox transport, which in turn delivers the mail using MAPI. But notice the arrow between the two, from transport to mailbox transport. That arrow is SMTP. So all cross-server communication is SMTP. No longer do we have MAPI calls across machines, like you had in 2010. And that has some advantages, and I'll talk about them a little bit later. But you'll see the same effect even when we look at submission. So what happens during submission, for instance? You have the database issuing a notify MAPI call to the submission service. We actually have a submission service in 2010 on the mailbox server. So you get a notify MAPI call. Submission service says, great, I have a mail item to pick up. It issues a MAPI call to pick that. It actually would inform the hub via RPC that, hey, you have a mail item to pick up. The hub would go and pick that mail item up using MAPI again and deliver it outside via SMTP. What about 2013? Again, it started with the same notify MAPI call. This time it was notify MAPI from the database to the mailbox transport service saying, hey, I have a mail item for you. Mailbox transport then issues a MAPI call, picks that mail item up, and now notice it issues an SMTP call to the transport service running on the mailbox server, which then talks SMTP to the front end and outside. So in both these cases, delivery as well as submission, you have cross-server communication using SMTP. And I don't know about you guys, but it's way easier for me to look at SMTP between two machines, debug SMTP between two machines. And SMTP, in my mind, was built to talk between two machines. And by having that, it brings a level of reliability, I think, which was not there before. And let me illustrate that point. I use Windows Explorer, for instance, or File Explorer, and I look at my files. And when I do that operation on a local box, almost always I'll be able to see the files on my machine when I open Windows Explorer. Now you try Windows Explorer and try to explore a file share on a different box. For the most part, it will succeed, but there are going to be occasional failures, and that's just how RPC is. And so having that cross-group communication be SMTP brings that level of reliability. Although subtle, it does bring that level of reliability. And secondly, notice that all MAPI calls are now, all RPC there is local. You only have MAPI calls between mailbox transport and your database, and that too on the machine itself. All right? You've seen this picture before. It was actually even there in the Ross's slide deck on Monday, yesterday. Seems like a long time. Anyway, so if you look at this diagram, you'll see that on your right-hand side, you have your enterprise network, and you have an array of CAS servers. You also have a load balancer sitting in front of the CAS servers. That load balancer's job is to basically distribute mail traffic across these CAS boxes. You also have a bunch of backends. So those backends are basically your mailbox servers, which have the transport and mailbox transport services running on it. Those mailbox servers are located in different DAGs. And on the left-hand side, you have your perimeter network, and you'll find that you could either use a EOP as your filtering mechanism, in which case you're extending your perimeter to some extent, or you could have SMTP traffic coming directly into your enterprise and hitting your CAS servers. That's just an overall illustration, and an illustration of where the three components for transport run. You have front-end transport, you have transport, and mailbox transport running in the back end. So let's take a very simple example of a mail coming in. That mail comes in via the load balancer. It gets sent to one of many CAS boxes. The CAS box looks up that mail, and its job in life, the front end especially, is to see which DAG that recipient belongs to. So it makes a call to 80 and determines which DAG that mailbox, that user belongs to. It belongs to DAG 3 in this case. And it will go and route or send that mail to one of the mailbox servers in that DAG. Now we'll talk in greater detail about routing and how that works. This is just a high-level view of understanding the various transport components, what the job of the front end is, and how it basically looks up 80 to determine which DAG that mailbox server belongs to. I haven't shown edge in that diagram yet, and I'll show that later too, okay? So that being said, let's actually dive a little bit in detail on each of our transport components. I mentioned before you have three components. There's front-end transport, and mailbox transport. Of the three, transport is the only component that's stateful. What I mean by stateful is that it's the only one that queues mail. It's the only one that actually saves mail, okay? The others are just passed through. Now, the responsibilities for transport remain pretty much the same. To summarize, you have taking mail from outside the organization, delivering it to the appropriate mailbox, taking mail from inside the organization, delivering it outside, as well as in the org. Along the way, we obviously do message processing, and there's a lot going on there, which we'll discuss in detail. There's message processing, and obviously there's extensibility. There's extensibility where third parties can plug in to various stages in the transport pipeline and do things on the mail. Finally, and this has drastically changed in 2013, is the redundancy aspect. And I'll talk a little bit more in detail about HA from a transport perspective, where we're looking at shadow copying and safety net and so on. So that being said, let's focus on the front-end transport component. So we know it runs on the CAS server. The front-end transport really has two basic pieces to it. There's an SMTP receive piece, there's a send piece. And the types of traffic it accepts, you have anonymous traffic coming on port 25, or you could have authenticated traffic, which we call client submission, on port 587. Now, in the case of anonymous traffic, the front end accepts that traffic, anchors on a recipient, and determines which mailbox server. I mean, its goal in life is determining which mailbox server to send that mail to. In the case of authenticated SMTP, it actually authenticates the user first and then determines which mailbox to send that mail to. And it communicates via the SMTP receive, or rather the SMTP send piece, either outside or to a mailbox server. So it talks to the transport component on the mailbox server. Now, there is one piece here which is also present, which is extensibility. Front door also does extensibility for you, so you can subscribe to various SMTP events along the way. I'll say this one more time, and that is, apart from providing a level of network isolation, if you will, because it accepts all the traffic on behalf of your enterprise, its job is to locate the mailbox. Okay, so its job is to determine, based on the mail I receive, which mailbox to send that mail to. Let's go on to the transport component. It's pretty much the brain center, if you will, for transport. And I have a diagram here that talks about transport. It's called MS Exchange Transport. That's the parent process or service, which spawns off worker process, which is the edge transport.exe process. You guys are familiar with that. But actually, I'm going to move on to the next diagram to explain this a little bit more in detail because there's more animation involved here. So this pipeline, if you will, this pipeline is known as the categorizer. The categorizer has various stages, most of which you are probably familiar with. But the thing to keep in mind is you have mail coming in, and when mail comes in and the hub, or rather the transport service, actually accepts that mail on port 25, it saves that mail in this database called mail.queue. So that's where mail will show up first. We will only accept that mail if we are successfully saved it, because we don't want to lose that mail. And only after that will we act back to the sender. So now that we have a copy of that mail, it becomes our responsibility to deliver that mail successfully. A copy of that mail is actually sent to the submission queue. All these queues that I've drawn here, by the way, this is all in-memory processing, right? So at any given time, if you were to restart the transport service, if you just went and restarted the box of the transport service, messages would once again be played back from mail.queue, go back into submission, and the whole process begins again. All right? So you have mail in mail.queue, it goes through the submission queue, and now what I have done is drawn these various lollipops that you see, the 4 of them. They represent the extensibility points for various third-party agents as well as internal agents that we have. So you have 4 of these along the pipeline, and we'll talk about each one of them and why do we need each one of them. So mail comes in through the submission queue, and that's the first extensibility point. Agents act upon that just because the mail has come in. A well-known agent internally would be the anti-malware agent, for instance. Its first thing that it does is look at that mail to see whether there are any viruses associated with it. The first piece of processing that happens inside the categorizer is resolving recipients. So when we get a piece of mail, that could have one recipient, it could have many. It could be assigned to a DL. It could be assigned to, it could come in with a proxy address, which now has to be changed into a primary SMTP address. All of those pieces of work happen inside the resolve recipients aspect. So we resolve all the recipients on that mail at that point, so we know exactly where that mail is or who that mail is being addressed to. If it's the DL, we would expand the DL at this stage. There was an on-resolved event, which was also present there, which I skipped, but that's where agents would subscribe. If they need to know, they need to come into play only after we have resolved the recipients. For example, the transport rules agent would come in there. It would look at that, would look at the resolved recipients and make decisions based on that. After we have resolved all the recipients, the next job of the categorizer is to figure out, where am I going to send that mail? Where do it could be going to a hub, another hub, or another DAG. It could be going to the mailbox. It could be going outside. So it needs to figure out what the next hop is, if you will, and the route for that. That's what happens in the routing stage. And after we've done that, the mail goes and hits the on-routed event, and those agents that have subscribed to on-routed can look at that there. Finally, there is content conversion and bifurcation. And I've shown you a bifurcated mail there. So if I had a mail, for instance, coming in, addressed to 2 recipients, one was external, one was internal, that recipient got bifurcated here. For the external recipient, we would potentially look up the remote domain settings for that user or that domain and determine that, hey, maybe we need to convert that mail from TNF into some other format, MIME, for instance, and send that out. So that's what happens at the content conversion piece. Finally, the mail, if I had a mail, for instance, sent to 2 recipients, one external, one internal, that got bifurcated there. Usually gets bifurcated at the end of the pipeline. One of the pieces of mail would go through the queue that's destined to the mailbox, and the other piece, or the other mail, would go through the external delivery queue destined for outside. But in both cases, you have different queues. And in general, I don't know, if you do a get queue on your mailbox server, as you probably have done before, you'll see a queue per destination. So you have many delivery queues, but you only have one submission queue. And at this point, that mail has gone out. It's passed through the categorizer and has been submitted. Now, I'm not speaking about HA here per se, but I'll speak about it in a later slide. The other thing to keep in mind is you have port 2525 present. So in cases where the transport service is co-located with the CAS role or the front-end role, in those cases, the front end will listen to port 25, while the transport service will listen to port 2525. So that's why you have both those ports mentioned. So in summary, the benefits for transport, the pipeline itself is there's extensibility for sure. It does all the message processing, and there's a lot of it, right? You have dealing with OOF messages, dealing with all sorts of different types of message formats, and so on. There's also routing that happens here. And finally, which we haven't discussed in the previous diagram, it's the shadowing. It's the additional level of protection. Finally, let's talk about mailbox transport. Mailbox transport also runs on your mailbox transport, or rather the mailbox server. And it's really divided into two pieces. There is the MS Exchange submission service. There's also the MS Exchange delivery service. And they pretty much do what those names suggest. Let's talk about submission, for instance. I mentioned to you the store issues a notify MAPI call to the submission service and says, hey, you know what, I have a mail item for you, please pick it up. For instance, you see the box there which I've shown, mailbox assistance. That's the infrastructure that we use to actually get notified. So when you click, for instance, on a mail and you say send, that mail actually, if for those of you at least using Outlook, that mail ends up, begins its life in the outbox. By the way, I had no idea about the outbox 1 year ago. I used to send mail, and that was pretty much it. But now I worry about, okay, is it stuck in your outbox? Maybe you need to look over there. But now, so you have mail that goes into your outbox, and that generates a notify MAPI call via the mailbox assistance infrastructure. The submission service is just another assistant if you go to see. And it receives that notify MAPI call, says, hey, thank you very much. Looks like I need to pick up a mail item. It picks that mail item and sends that via SMTP out to the transport service. That's when that mail leaves your outbox and goes into your sent items folder. So when we've seen, for instance, issues in the data center with mail getting stuck in your drafts or in your outbox folder, usually is maybe the submission service on that box was not running or needed to be kick-started, if you will, so that it picks up that data. The same thing, but in the reverse order, happens with the delivery service. So the delivery service receives mail via SMTP on port 475, and when it receives that mail, its purpose is to make store driver calls into the store and basically save that item. Okay? Now, there's also, in the delivery pipeline, sometimes there are delivery agents sitting there that need to issue side effect messages. For instance, if you had a delivery receipt requested, when that mail came in and a delivery receipt was requested, that mail would actually pass through the SMTP send component that lives inside the delivery service. OOF messages, same thing. When you have inbox rules run, and now that message needs to go through your SMTP send. So that being said, mailbox transport truly subscribes or brings together the vision of the server is an island model. And that's because you have one box, and on that box, the only component that's talking to the store is your mailbox transport. And usually, what that means is when you take a box out of maintenance and then you upgrade it, for instance, and so on. All the components on that box, for instance, are of the same version. You have to worry less about backward compatibility because they're all upgraded at the same time. They're all talking locally, versus having to worry about breaking compatibility from one machine talking to another machine. Because of that communication being SMTP now, that becomes less of trouble. It's more or less just that stack that gets upgraded at the same time. And so that's another benefit of having the every server as an island model. So to complete the architecture aspect, I showed this diagram to you before, but we also have a lot of folks here, and I know when I remember Ross in his first session asked folks to with their raise of hands, tell who actually uses Edge, and there weren't that many. So I'm curious to know. There were only 20 hands in that audience of 500 people, and I'd be curious to know, even from this audience, for instance, how many folks actually use the Edge role. If you could raise your hands to know if. Okay, it looks like the same 20 folks showed up here too. Which is good. I do have one slide dedicated to the Edge role, so you'll be pleased about that. So we shipped Edge in 2013, but in SP1. We didn't ship it when we RTM'd. Now, a lot of folks use the Edge because in their perimeter, of course, because it's non-domain joined. Right? So it's a non-domain joined machine. The CAS role, as well as the mailbox server, of course, they're all domain joined. And so they like to have a non-domain joined in the perimeter that accepts their mail. So that hasn't changed. The requirement from that perspective is still the same. The CAS role is still domain joined. So if you were truly requiring a machine non-domain joined in your perimeter, you would go ahead and deploy an Edge role. It has the same features as 2010. Nothing has changed there. The potential only difference is the fact that it uses the new monitoring framework, which means you get managed availability on the Edge, just like you get managed availability on the rest of your transport components. But you've got to keep a couple of things in mind with the Edge. Number one, there is no AV. Number two is that it does offer basic anti-spam, but there's no shadowing either, which means if that mail came in and it hit your Edge server and you queued mail, obviously, on the Edge, and it were to have a catastrophic failure, it kind of died there, you would lose that mail because when it accepted that mail on the Edge, it did not make a copy on another machine, unlike the transport service role, which we'll talk about soon. Finally, if you were to still use client submission does not go via the Edge. It still goes and hits your CAS boxes. So that requirement still remains for the CAS if you are using client submission. And notice the difference here is that the Edge transport role, it doesn't go via the CAS. It actually goes directly and talks to your mailbox servers. And it uses Edge Sync to basically sync information from your network, from AD, and give it to the Edge role that's sitting in your perimeter network. That's the dotted line. All right, so that being said, so we've covered the roles to a great extent. Let's look at routing in greater detail. And I'll be trying to explain this using 4 scenarios. If there's one thing to keep in mind about routing, and I'm probably going to belabor this point very often, is the basic algorithm, how it works for routing. And I've given the example of the CAS server here. So you have the CAS server. The first thing it does is it attempts to anchor on a recipient. You could send a mail, it could receive a mail for maybe 5 recipients, 10 recipients, it doesn't matter. It'll anchor itself on one recipient, and it'll look up AD to find the DAG that this recipient belongs to. Once it finds that out, it's going to try to route that mail to a mailbox server in that DAG. It could route that mail to any mailbox server in that DAG, but it prefers to route it to a mailbox server that's in the same site as the CAS server. So it'll first look to route that mail to a mailbox server in the recipient's DAG that belongs to the same site as itself. After that, it could route to any, if that is not available, it could route to a mailbox server in any mailbox server in that DAG. So with that in mind, let's go through the actual mail flow. So this is a very simple example to begin with. You have mail coming in. This is a single server box, has the CAS role and mailbox server role co-located on it. It's one DAG. I don't think any of you have this configuration, but this is just to illustrate the point. So you have mail coming in. It's received by the front-end transport on port 25, and front-end transport will look up the DAG for this user, for this recipient, and will route that mail to the transport service that's sitting on the mailbox server. It's co-located, so transport server will receive that mail on port 2525. It will process that mail. We went through that whole pipeline, remember? It'll process that mail, and then it will route that mail via SMTP to the mailbox transport service on port 475, which will then make MAPI calls to the store. So that's the general framework of how mail will flow, in this case, a single server. Now let's look at the protocol stack. And that's what makes this interesting. With SMTP, it's very easy to show the whole flow from start to end, which was a little bit harder when we had MAPI in between. So in this case, mail came in from the internet. You had the usual SMTP handshake going on. And you had, as soon as the front-end transport started receiving data, actually on end of headers, it now knows the recipients that it needs to send mail to. Once it knows the recipients, it anchors on one, as I mentioned, and it will now open up an SMTP session with the transport service that it wants to send that mail to. So we have the usual SMTP dance, if you will. However, it starts off with a TLS session to encrypt that mail between the front end and transport. There's also exchange auth going on where the front end needs to authenticate with transport before it can use the xproxy from verb. That's a proprietary verb. That xproxy form basically informs the transport service that, hey, this mail, even though I'm sending it to you, transport, it's actually coming from this particular IP from this particular sender. So it does nothing but relays that information to the transport service. The transport service says, thank you, great. There's the usual mail from receipt to. And then that piece of data that was sent from the client passes through front-end transport to transport. And that's where it gets saved. Transport is the first role that actually queues that message. And at that point, once it has successfully queued that message, that's when it replies back with a 250 OK. Oops, I should have gone forward. Which then sends it, relays that back to the client. The front-end transport will say, I'm done with that mail. The client closes the session, which is then relayed back to transport. This is the way that mail item flows from a client to the transport service. And I have not described to you shadowing yet, so I will talk about that soon. But this is the crux of mail flow going to transport. Now, once transport has processed that mail, it's going to try to deliver that mail to mailbox transport. Again, it does the SMTP handshake. You have a TLS session established to encrypt that mail, followed by exchange auth, followed by this yet another verb, which is the X sessions params verb. And what that verb, if you actually look at the stack, you'll see that that verb has an extension there which says, please deliver this to this mailbox. So transport is informing mailbox transport that please deliver this mail to this particular mailbox. And that's what mailbox transport takes, the rest of the verbs you know. And it will take those and it will deliver that message via MAPI to the store. Once it has done that, it responds back with a 250 OK, and the session is closed. So that's really how the full stack works from start to end. And you can see this exact same thing if you look at protocol logs on these machines. The SMTP send and receive protocol logs will describe this in even more detail. So what about the received headers? Let's talk about that. So if I were receiving that piece of mail that I showed you on that one box, say from Woodgrove, I would get that the first header I'd see is basically when that mail passes through front-end transport. The second header I would see is when that mail passes through transport. And the third header I'd see is when the mail passes through mailbox transport. So if you were doing this experiment on the same box, obviously, because it's the same box, the name of the machine is repeated in 3 places, in 3 separate received headers. But really what it's telling you is, via SMTP, I have transferred that mail first from outside to the front-end transport role, then from front-end to the transport role, and finally from the transport role to mailbox transport, which finally gets delivered to the store. And you'll see those names there. You'll see front-end transport, which I've highlighted in there. You'll also see mailbox transport. So you would know when you debug information, hey, where did it spend most of its time? Why was it spending most of its time while delivering from transport to mailbox transport, for instance? So let's look at another example. You have incoming mail to 2 recipients now. This gets a little more interesting. I'm going to use colors here. So you have these 2 recipients are Mr. Red and Mr. Green. I mean, please don't go any deeper into those colors. They're just meant for illustration. So Mr. Red and Mr. Green are going to be our recipients for this mail. When that mail comes in, it follows the same. It hits one of the cache servers. It happens to hit this one because this one is where the load balancer sent it. Notice that from the front-end transport, it went directly to transport. And I stopped there because that's the first place where mail actually gets queued. Front-end transport was just a proxy to send that mail to the right mailbox server. Now, the reason why it chose this mailbox server is because it looked up one of these recipients. It anchored on one. It looked up one of these recipients. It found out that the DAG for this recipient. And then it said, hey, I'm going to send this mail to one of the mailbox servers in my DAG, but I'm going to prefer sending it to the mailbox server that is in my site. And so it sent that mail to that mailbox server. And the mailbox server, or rather, the transport service on that server accepted that mail, made a copy of that because there are 2 recipients involved once it went through its processing. And then it sends the first mail via mailbox transport. Again, went quickly through, right? It did not it wasn't stored there on mailbox transport and went to the store. Similarly, it went from transport to mailbox transport to store again on the other box. Notice that within a DAG, a transport server service rather, when I say transport server, I mean the transport service running on the box. That transport service can talk to mailbox transport on any machine in that DAG, which is within the DAG, okay? So the transport service spoke via the mailbox transport and delivered that message to store. Now let's talk about originating mail. So now this is mail that, in this case, Mr. Gray wants to send to somebody on the internet. And what you'll find is that that mail will again go to mailbox transport and get delivered to a transport service that's running on one of the machines in that DAG. Now, in this case, the reason why the mailbox transport chose a different machine is purely a redundancy. Mailbox transport doesn't want to deliver it to the transport service running on the same machine. Because right here, for instance, you will see that you have a copy of the machine in the store on mailbox 1, and you also have a copy in the transport service on mailbox 2. So purely for redundancy, mailbox transport will not choose to send it to itself. Now, if it is the only machine in that DAG, it will send it to itself. After that, transport will process the mail. It determines that this mail is going outside, and it will send that mail via the front-end transport service to the recipient outside on the internet. So how does this look from a protocol flow standpoint? This time, I'm going right to left. So you have mailbox transport establishing a session with transport. It does the usual SMTP handshake, once again, TLS followed by exchange auth, and it just sends the mail using the regular verbs that we know to transport. Transport, once it accepts that mail, it's going to issue a 250 OK, and the mailbox transport service is going to basically close that connection. Transport now has a copy of that mail, that piece of mail. That's when it gets interesting. Transport now wants to deliver that mail outside. So in that case, you'll see a different verb now used, which is xproxy2. Transport service does not directly talk outside. It could, if it was configured that way, but you could also configure it to talk via the CAS role. So it's a configuration that you can make to talk directly outside or talk via the CAS. And usually from a symmetric standpoint and from a network isolation standpoint, it may not be a bad idea to just go via the CAS. So once we go via the CAS, the transport service is telling the front-end transport, hey, you know what? When you send this mail out, this is the destination I want you to connect to. This is where I want you to send that mail to. And that's the communication that goes on in the xproxy2 verb. Front-end transport at that point makes that connection to the destination. And after that, you could pretty much look at that front-end transport as a blind proxy. It's simply, there's no conversion going on there, nothing. It's just picking up what it's given from transport and sending that over to the server on the other side. So if you look at the full picture here, you have mailbox transport talking to transport, and then transport proxying the information via front end to the destination server. The destination server, though, when it looks at, when you see the received headers on the destination, it will actually show you the IP address of the front end. It won't show you the IP addresses of any of the transport service that send that mail. So now let's look at a little more complicated routing option here. I have a set of CAS servers. I have 2 DAGs. Each DAG is actually having a server in a site. I haven't shown the site for DAG 2, but you have DAG 1, which has 2 servers, one in site A and one in site B, and DAG 2, which also has 2 servers, one in site A and site B. Now, Mr. Gray is trying to send a mail out, and the recipients he's sending to are residing in different places. So one of the recipients, Mr. Red, is in the same DAG as Mr. Gray. The other recipient, Mr. Orange, if you will, is not in the same DAG, but a different DAG. Okay? And finally, you have the user on the internet that's also a recipient of this mail. So let's see what happens. Mail will go via mailbox transport. Again, this is always local. I mean, that doesn't change, period. Mail goes to the local mailbox transport service to be delivered to transport. And now in this case, mailbox transport also anchored on one of the recipients. Say in this case, it anchored on recipient Red, and it looked at that recipient and determined which DAG that recipient belongs to. It figured that it belonged to DAG 1, and as I mentioned before, it chose a server that's not itself to route that mail to. So it chose, for redundancy purposes, the other server, and it made a SMTP connection there, and you got that mail delivered to the transport service on the other box. The transport service there processed the mail, figured that there are 3 different recipients to send that mail to. It sent the first mail via mailbox transport. It was a local delivery to the store. It sent the second piece of mail via the casserole, the front-end transport, to the user on the internet outside your org. And finally, the third piece of mail, it found out that that user is not in my DAG. That user belongs to a different DAG, and so I'm going to try to route that mail to a server in that DAG. And it happened to choose one of these servers. So this server will then do the needful. It'll process that piece of mail. It'll actually make a shadow copy of that mail also, and then process it and send it via the mailbox transport service to the store. So that kind of completes our routing piece. Sure.
Sorry, no, just real quick, just so I understood. You were saying that you configure, I think, the transport to send directly out?
That's correct.
Versus the front-end transport?
That's correct.
What would be a reason why you want to do that?
To send it through front-end, or what is the reason of not sending it through front-end?
Yeah, that's what I'm asking.
Okay, I mean,
Why would you not want to send it? Why would you configure it not to if that's the way you guys have set it up?
the question was basically, would you prefer sending the mail via the front end, or is there any reason for us not sending it via the front end? And honestly, I would have preferred sending it through the front end. The only reason why I would think of folks sending it via the back end was because they've been used to that by the hub role, for instance. And they've used to that mechanism, and they're comfortable with that, and they would keep it that way, for instance. So
The recommendation now is to combine the whole thing, right? So your CAS.
that is correct. That's pretty much how we run our service too. So yeah, it goes via the CAS box out. Yes.
Thank you.
Yeah, no problem. Okay. So let's move on to the next slide, which is transport high availability. Now, a lot has changed, by the way, in this area between 2010 and 2013, a lot of which you will like, I think. So let's go through the text first. Mail comes in to the transport service. Remember, of the three roles that I mentioned, or the three components, transport service is the only component that does a shadow. No other transport component does it, okay? Neither the mailbox transport nor the front end. Transport service will make a shadow. It'll prefer to make a shadow of that mail on a server that's in a different site from where it is located, just to get that site resiliency. And it will reject the mail if it is unsuccessful in making a shadow. So if it got a mail and it tried to make a shadow, it would prefer a different site. If that failed for whatever reason, it would resort to a server in its site. And if that failed too, it would actually reject that mail, and the sender would get a 450 response and would have to try again. The other thing is, so once it has made that shadow, it's now the responsibility of the shadow server to determine whether the transport service, the primary server, has sent that mail or not. So it keeps doing an SMTP ping, if you will. Again, SMTP, keep in mind, cross-server communication. It does an SMTP ping with the primary saying, hey, have you delivered this mail? Hey, have you delivered this mail? And the primary, finally, when it does deliver the mail, will get back to the secondary and saying, yes, I have, in which case it will save a copy and move on. But in the case where the primary is unavailable, and I keep pinging the primary, and after 3 hours or so, I'm done with my attempts to ping the primary, I will send that mail on behalf of the primary. So the shadow server will send mail on behalf of the primary 3 hours later. It's, again, a configurable value. I think the default is 3 hours. And when that piece of mail gets sent, that's great. It's 3 hours late, but it's at least sent. The second piece, though, is when the primary comes back up, say 6 hours later, and it has no idea that the secondary has actually sent that mail, so it will also attempt to send that piece of mail to the destination. So in the case where that destination is a mailbox server, Exchange, the store will make sure that you don't have a duplicate delivery, so you won't see that second piece of mail. But if that mail is actually sent to the internet or to a non-exchange box, chances are you could get a duplicate delivery there. So that is the side effect, if you will, of having shadow redundancy. Safety net goes hand in hand with shadow redundancy. So remember I mentioned that the primary server, when it receives the mail, it makes a shadow and then goes about its usual business of sending that mail. Once it has finished sending that mail, it actually saves that mail. It saves that mail, and it will keep that mail around in its database for, I think, a default of 2 days, and you could configure that and make that different too. So you could make it 7 days, 8 days, depending on how much disk space you have. But it would keep a copy of that mail, and that's what we call safety net. Simultaneously, you also have the secondary or the shadow server. Once it finds out that the primary has sent the mail, it will also keep a copy of that mail in its shadow. So you have two safety nets, if you will. You have the primary safety net, and you have a shadow safety net. And let's talk about that with an example. What I've shown over here is also the commandlet that you would use to actually determine what the limits are for your organization. So if you want to change these limits, those are the parameters that you would change. So let's see what happens now with mail coming in from outside. So this case, the mail is destined for Mr. Red in this DAG. Mail comes in via the usual route. You guys are now very used to that diagram. It came in via the cache server, and it was sent to transport. Now, what I didn't show in the past, which I'm showing right now, is you'll notice that the transport service, before accepting that piece of mail, has shadowed it. So it has made a shadow via SMTP to one of the shadow servers that it has picked in a different site. It then goes about its usual business of sending that mail to the store. And once that is done, it will save a copy of that mail. You can see a very light piece of mail there in its database. It'll save a copy of that mail in what's called its safety net. Okay? Then you have the shadow, which is constantly pinging, basically, via SMTP. The primary is saying, hey, have you delivered my mail? Have you delivered my mail? And finally, when the transport service says, yes, I have, the shadow server will also save a copy of the mail in its what we call shadow safety net. That's on disk. It's not in memory, so it's not occupying any space there. But the point is, right here, you have 2 copies of this mail, so that if one went down, the other server can send that piece of mail. And the more important piece here is it assists the store in case there's a logical corruption. So keep in mind, this is within a DAG, so it's within the high availability boundary, if you will. If the store server ever had a logical corruption and that resulted in 3 of the 4 active copies basically having trouble, and so you had to resort to a lag copy, and you had to retrieve a bunch of mail because the lag copy is obviously missing a bunch of mail. Where do you get that mail from? You would get that mail by querying the safety net. And either the primary safety net or the secondary safety net, shadow safety net, could service that request. And so you have 2 copies essentially available for you in case the store requests for that. And we have seen occasions where that has been required. So how does this work from a protocol standpoint? I mentioned this to you. Remember, this was my first protocol flow that described how mail flowed from the internet and hit the transport service. Well, I did lie a bit because that's not really quite how it flows. So I removed 2 statements there. As soon as we'll pick up where basically transport left off. Transport service, the first server that received the mail, when it received data, it started receiving data, it's trying to make a shadow now. So it's going to establish a TLS session again with one of the other mailbox servers. It's going to, you got this new verb, the X shadow request verb, which will basically inform the service. This is again over port 25, so that hasn't changed. It's not a different port. Saying, hey, you know what? I have this mail to shadow. Can you please shadow it for me? And it basically sends all the pieces of, all the SMTP verbs after that. So you have mail from, receipt to. Once the shadow has accepted all the data, it says, I'm okay. The transport server, the primary server, will issue a quit, close the session, and relay that back to the front-end transport, which will relay that back to the client sending that piece of mail, and finally that session closes. So what you really see here is the entire flow when a mail actually gets accepted by the transport service on a machine. Quite a lot of hops, right? Anyway, then you look at the protocol flow between the shadow server and the primary server. So what you see here is the shadow, every 2 minutes, I think that's the default value, is making an SMTP connection with the primary, saying, establishes a TLS session, does an auth, and then issues an X shadow verb and says, hey, I'm pinging you, I'm finding out whether you have any messages for me that you've delivered already. And so if in response to the X discard event or XQ discard event, the primary will follow that up with a 250 OK and also send the message GUID. It's not the message ID as we know it, like the internet message ID, but it's a message GUID. It's a GUID that informs the secondary or the shadow that, hey, I have actually sent this mail, so you can safely discard it. All right? So that's what it does. And once the shadow receives that information, it closes the session, and it's done. So it does this. This constant chatter is happening every 2 minutes. So how does this, let's bring all of this together, if you will, all the previous sessions, and look at this from a message tracking log standpoint. Now, I think most of you are familiar with message tracking logs, and I use it all the time when we're debugging issues in the data center. So let's look at how Mailflow actually works from message delivery and submission standpoint. So on the left-hand side, you have message delivery. Mail comes in to front-end transport, which then gets delivered to transport. You will see an SMTP receive event on the transport box in your message tracking log if it has successfully received that message. Prior to receiving that message, though, it has made, as you can see, that's number 3, it has made a shadow copy of that message. So you will see an SMTP HA redirect message on this box that's making the shadow copy, followed by an SMTP HA receive message on the shadow server saying that it has received that message. The transport service will then go about its business of delivering that mail. So you'll see an SMTP send event on the transport service sending that mail to the mailbox transport service, where you will see a store driver deliver event when it successfully delivers that message to the store. Finally, the shadow, every 2 minutes, as I said, is talking to the transport service, finding out whether it has delivered the mail or not. And once it has figured it has delivered that mail, it will issue an SMTP HA discard message. So this is the typical mail flow or mail flow pattern that you will see in the happy path scenario for message delivery. Now, what I have not shown in this path are a bunch of messages that you will also see or in the message tracking log on the transport server itself, on the transport service itself, like agent info, you'll see routing messages, routing redirect, and so on. But those are all associated with the work that's going on in the categorizer, okay? But those vary all the time, depending on the message you see. But these are at least the standard messages that you should see in a happy path scenario. What about submission? It's the other way around. So you have mailbox transport receiving a message. So you see a store driver receive event. Prior to that, you'll actually see a MAPI notify event also in the message tracking log. So you'll see that event too. But you'll definitely see a store driver receive event if it has successfully received that mail, followed by a store driver submit event that will go, once it has successfully submitted that message, to the transport service running on the other box. The transport service will basically log a SMTP receive event if it has successfully accepted it, and once again, an SMTP HA redirect followed by a HA receive on the shadow server. So that path doesn't change. Doesn't matter where mail is coming from. If the transport service receives the mail, it will make a shadow, and that's why you will see an HA redirect followed by an HA receive. Sometimes you'll see that, hey, why did Mailflow not work? Because you don't see an HA receive event for the corresponding HA redirect, which basically means maybe that failed. So you'll see an HA redirect fail, for instance. So you will know the reason why mail was not accepted is because that service could not make a shadow copy on the other box. So those are the things you need to look out for. And finally, you'll see an SMTP send event on the transport service when it sent that event over to successfully, and an HA discard on the shadow server when it has found out that the primary has sent a message out. Okay, so this is what you should expect in a happy path scenario for message tracking in this submission and delivery case. Finally, let's spend about 5 minutes on client submission. That's the last piece I have here. I'm actually curious to know how many people use client submission in their organizations. Can I see a raise of hands? I'm not seeing too many. It's even fewer than the edge. There are about 5 people. That's good. I'll spend all of 5 minutes on it in that case. But I didn't know. It's been a while since I used one of these clients, so I really didn't know what client submission even meant when I first joined. I go back to my old Outlook Express days where you had the client, and Outlook Express was using SMTP to send the event, to send a message to the server, and then use POP and IMAP to actually retrieve it. And we have a bunch of customers who use other clients, like Thunderbird is a popular one, I believe. And for them, client submission is what they use. So in situations like this, and actually I have a Thunderbird UI there. Clients, as I said, use SMTP to send mail, POP IMAP to retrieve. The one thing to keep in mind, though, is that when you send a mail using client submission, that mail does not go into your sent items folder. So when you send mail via Outlook, you will notice that the mail goes to Outbox and then your sent items folder. That is not the case for client submitted mail. Okay? So let's give an example of that. Say I have an organization that uses client submission. There is a user who has a mailbox in mailbox server 1 in DAG 1. That user happens to travel to a different site. So you had, say, North America and you had Europe. The user is now in Europe and uses their client, Thunderbird client, to send a mail. When that piece of mail is sent by that user in that site, it goes to the front-end transport service in that site. Now, the algorithm is slightly different. The front-end transport still tries to find a mailbox for this user, a mailbox server to route to. It knows that this user is in DAG 1, so it wants to look for a mailbox server in DAG 1. It will actually look for the mailbox server that this user belongs to. And so it will actually send this mail, incorrect, not back to him, but actually it will go to the mailbox server, to the actual mailbox server that hosts this user's mailbox. This is for client submission only. If it cannot find a mailbox server, if that mailbox server is down, it will look up any mailbox server in the DAG. And assuming this user actually wanted to send mail out, it'll go from there via the front-end transport role outside. So, don't confuse this with general routing. This is really specific to client submission. So for those of you not using client submission, you can just erase this out of your memory. And this is kind of the protocol flow. Notice it's very similar to the protocol flow for mail coming in via the anonymous channel, but there is no mail flow between transport and mailbox transport. And that's why I said there is no mail actually going into the mailbox transport service and the store. Again, if you're not using client submission, do not confuse yourself with this diagram. You can ignore this piece. So that pretty much wraps this session up for today. I do have two unplugged sessions, one after this one, as well as one tomorrow in case you have Q&A. So just to summarize what we have here, and we still have about 5 minutes, so I'll take Q&A right now too. To summarize, we discussed the various roles in transport that were not there in 2010. We discussed what the functions of each of these roles are. We also understood 4 important things in my mind. One is that all mail communication between servers is SMTP. You'll be looking a lot more in your protocol logs if you weren't looking before. Number 2, submission and delivery to a mailbox is always local, whether it's submission or delivery. Mail is always routed to the DAG where the recipient belongs. So for a particular recipient, the goal is to route it to a DAG where the recipient belongs, ideally to a mailbox server that is in the same site as the CAS. But in the case of mailbox submission, I mentioned, it'll try to find a server that's not itself. So it will route it to another server because of redundancy purposes. And finally, we spoke about the improved shadow redundancy and safety net that we have in 2013. So with that, thank you very much. And I'm opening the floor for questions. Thank you. Yeah.
So where do you look for logs? Do you have to look everywhere?
No. So the question is, where do you look for logs? The logs are present in the transport logs folder. And usually, when you go there, you would actually look at, in the transport case, if you're looking for protocol logs, it is in the transport. It's called the hub folder. You know that? Or sorry. Which server? So it'll be present on all the servers. You have protocol logs on the front end. You will have protocol logs on the on the mailbox server. So you can look at either one of those protocol logs, because the protocol logs on the front end are basically containing receive and send that the front end does, and protocol logs on the transport server is looking at mails that are received by the hub and sent by the hub, as well as by mailbox transport, received by the mailbox transport and sent by the mailbox transport. So there are folders there which will describe to you which protocol logs to look at.
Again, so we have 3 boxes running the multiple.
Yeah? You could have 3, you could have 1, you could have 2, it depends, right? But yes, you will look at all 3 of them if you wanted to see end to end. But usually I center on the transport service. So look at the transport service, because it'll have, so if you look at this diagram, for instance, you will see protocol logs. If you look at the transport service, you will see send protocol logs and receive protocol logs on that box. So you will know what it has sent and what it has received. So I would focus first on that one.
In this slide here, when you've got MDX2 and MDX3, the dotted line is over to the other one there. Is that the shadow?
That is the shadow copy. That is the shadow. The dotted line is the shadow copy. Yes.
Hi. On that message submission, sending from Outlook with Exchange 2013 in DAG environment.
Yes.
When submission queue is suspended, should that suspended queue receive emails from Outlook client?
This is for the submission service. The submission queue, by the way,
Yeah,
is not on the mailbox transport server. It's on the transport. It's in the transport service.
Okay.
Right? So it is going to, Outlook will still try to talk to the mailbox transport service to basically send mail. If you have submission service, there's a difference between submission queue and submission service. I want to make that clear.
Yeah.
Right? So the submission service, if it was, as long as it is running, it will try to accept mail from Outlook and try to send that mail out to the.
despite
That
the
is correct.
submission queue. Why?
Because
I
it'll
just-
try to contact, because it will try to contact any of the servers in that DAG to send that mail to. So just because submissions queue is suspended on one box, there's no reason why it cannot send mail to another box.
So what happened to those emails? The submission queue is suspended. It receives email, and you can't, process the email until the suspension is lifted. So, how do you detect that problem? Let's say you have submission queue accept like 1,000 emails, and someone didn't know about that, or 10,000, whatever the number is.
Yeah.
Someone didn't detect that problem, and then people start getting NDR, and people saying, "Oh, I'm not receiving emails." And
So in normal circumstances, if you have multiple transport servers, then just because submission queue is suspended on one box, doesn't mean that the other boxes cannot accept mail.
I understand
Okay,
that. So,
but say all of them have somehow happened to be suspended.
suspended queue, the problem is that suspended queue is continue to accepting email, and that's where the problem is, I think, because the suspended queue will accept the email, but it doesn't know what to do with it because it's suspended.
And why did it get suspended?
Well, that's unknown reason, and that's besides the point.
Okay.
But there was an incident where, for whatever reason it got suspended, everything is active, but it continued to accept email, and that's where, I don't really understand why it's accepting email when it's suspended state. Because it should, because you have so many other servers that can accept emails and process that.
That's right.
When it's suspended, it should not accept, it just should reject that regardless of what the services are running.
But it did the whole. I've not seen the whole submission queue being suspended. Usually messages are suspended within the submission queue.
Well,
So that's very different,
that's
right?
different.
Yes.
Yeah, I'm talking about submission queue being suspended and not suspending a message.
Okay.
Yeah.
Interesting. So I understand what you're saying from a perspective of why are we accepting messages in that queue? Why can't we, for instance, just go into draining mode or change the component state so as to prevent the server from being accepting messages?
Once it's suspended, it should not accept email. Just like when you stop transport service, it doesn't accept email. It should go to different servers you got so many other servers that can accept emails, you don't have to depend on just one service on there.
I see. Okay. No, so I will have to go back and look at that in terms of what we can do there.
And I do have an active case, and that's the answer I receive, and that's why I like to review why that's designed that way, because it really does not make sense from my point of view, and I'm sure from a lot of people's point of view that it just doesn't make sense.
Okay. Let me go back and talk to my team and then see why is that the case, for instance.
All right.
I don't have the answer for you right now, per se.
Okay, thanks.
Yeah, cool. Thank you. Hi.
Do you have some scenarios for application servers? We have about probably 200 or 300 various applications that are submitting email either anonymously or with 80 credentials, all on port 25 to one of several receive connectors on 2010. So as I start to move to 2013, what are some things I need to consider where I point those application servers?
I would think you'd probably point them to also the transport service, right? So this is mail coming from these you could either do via the front end if you wanted to, or you could go directly to the transport service to send mail. I would probably, if these applications, depending on where they are living, I would probably go through the front end transport service to send that mail.
All on the network.
Okay. So I would probably use the front end for that, just like I would use for mail coming from outside.
So I can still create custom receive connectors that do a combination of either accepting anonymous mail. It looks like CAS already has a built-in receive connector.
That is correct.
Anonymous on 25.
That is correct.
I assume it also does authenticated on 25?
No, on 587. That's client authentication.
Okay. Can I create a custom connector that does authenticated email on 25?
I do not have the answer for that. I don't know. But again, that's another thing I'll find out. So you want your client to actually authenticate on 25 with I think it should be possible because we authenticate between our servers all the time on 25. We don't use 587 for that.
Okay.
so it should be possible. It should just use the exchange auth like how we use between our two servers, right? It should be exactly the same.
Okay. Just want to make sure it ports.
Yeah, no, it should be the same. I can't see it being different.
Thank you.
Yeah, thank you. I'm actually I'll step down and I'll take your questions outside because I'm actually stepping down, so I'll meet you with you guys right now. It's just because I'm 5 minutes above and I want them to prepare for the next session, okay?